The sum of the last three terms of a geometrical progression having n terms is 1024 times the sum of the first three terms of the progression. If the third is 5, find the last term. Make sure you understand the question. Now, the sum of the last three terms. So we are dealing with geometric progression, and in geometric progression you have the first term. So the second term will be first term multiplied by the common ratio. So the third term, first term multiplied by common ratio, then raised power 2. So and so on till you get to the last term, first term multiplied by common ratio, then the number of terms minus 1. Because they said that having n terms, so we do not know the specific number of terms that we have, so you cannot stop at anywhere until you get to the last term. Now we are dealing with sum, so let's add. So it's series, you add, then till you get to the last term. The sum of the last three terms. So this is the last term, a multiplied by r raised by n minus 1. So the second to the last term is going to be a r, then n minus 2. Then plus third to the last term is going to be a r n minus 3. So this is the sum of the last three terms. So this is it. Now let's add the sum of the first three terms also. The sum of the first three terms will be the first term plus the second term, then plus the third term. So here they say that the sum of the last three terms of this GP is equal to 1024 times the sum of the first three terms. So what we're going to do now is that we have the first of the last three terms. Let me write it. Sum of the last three terms of GP. And here is the sum of the first three terms of GP. So the sum of this equation 1 is equal to, so a r n raised power n minus 3 plus a multiplied by r raised power n minus 2 plus a multiplied by r and minus 1 is equal to 1024 multiplied by the sum of the first terms, the sum of the first three terms, which is a plus ar plus ar squared. Now from here, now we can factorize common variables there. So from here, we can let it be in form of the sum of the first three terms. So from here, I can factorize r raised power n minus 3 out here. So I will have a, then plus ar plus ar squared. So you can simplify it. Please expand it so that you see that it is correct. I do not want to waste your time, that's why I want to quickly do it like this. So from here I have 1024 multiplied by a plus ar plus ar squared. So from here I can cancel the sum of the first. You can see that I have the sum of the first three terms a, and I also have the sum of the first three terms at the right hand side. So I have cancelled them now. So I'm left with r raised power of n minus 3 is equal to 1024. So this 1024 is the same thing as 2 raised to the power 10. So you can check your calculator. So from here I can now say that r raised to the power of n minus 3 is equal to 2 raised to the power of 10. So from here we can assume that n is an integer and n is also an integer. So assuming that r and n are integers. So invariably I can say that this r is equal to 2. So r is equal to 2. Then the exponent n minus 3 is equal to 10. So from here I can now say that my n is equal to 10 plus 3. So n is equal to 13. So we have 13 terms in this geometric progression. And the common ratio is equal to 2. And we are asked to find the last term. So the last term of GP, or the nth term, is equal to a multiplied by r raised to the power n minus 1. So from here, I need to find the first term. So from here, I have my third term, which is a r raised to the power 2 is equal to 5. So let's substitute the value of r there, which is equal to 2 squared, is equal to 5. So this is 4a is equal to 5. So divide both sides by 4. So a is equal to 5 over 4. That's the first term. So now I can now substitute the value of a, the value of r, and the value of n in the last term. So the last term is going to be, anywhere I see a, I'm going to put 5 over 4. Anywhere I see r, I'm going to put 2 raised to the power of 13 then minus 1, because n is equal to 13. So the last term is equal to 5 over 4 multiplied by 2 raised to the power 12. So I have the last term is equal to 5,120. So that's how to do that.